Good morning, everyone. Our last lecture, at least the last topic, we need to review recursion with Prolog. Our schedule, we finished with Prolog today. You're going to have a quiz and homework. Final review, I am going to ask Jacob to help me with that. The idea is to have this session December the 1st, next week, to check common questions, common problems about everything from C, C++, Lisp, and hopefully by then you are done with your homework, and therefore you can also ask questions about Prolog. Please feel free to suggest ideas, topics, questions for the review. Let me be clear. We finished today, and the reason for finishing today is you have at least this week to review everything that is going to be on the exam, to take a look to your notes, the slides, the video lectures, if you need to review some of them that you didn't attend or you miss, or you need a little bit more explanation of things like C++ or pointers, for instance. You have time. The goal is for you to use the week to study. During the week, probably you're going to have questions, and there are going to be things that maybe you do not remember or you need more information about it. My suggestion for those questions, you can send us emails, and what we can do excuse me, is to put those in the review. So answer that in the review, which means that not only you, but other people that maybe have a similar question could get the information that you need. The review is just a couple of days before the exam. So waiting for the review to start studying is a very bad idea. The review is just the point in which you already review everything, you have some particular questions, and maybe we can answer your question during this 1 hour session. And it's still 2 days for you to do the final check before the exam. That could be my suggestion regarding how to schedule your time. So final exam, December the 3. During the lecture time, as usual, Thursday, 10:30, we do not have a meeting in Zoom. You go directly to the logged on browser, open your exam, complete your exam, submit, and that's it. We're going to try to finish the grading as soon as possible. So last topic today, our last lecture with a new topic. Next week, final review, our last lecture, only 2 answer questions, reviewing, presenting examples of the questions that you could have on the exam, but hopefully by then you have already studied and reviewed things. So just closing things and then your exam, and we are done. Good. Also today, as I mentioned, we finished with Prolog. Therefore, today you have open quiz 5, homework 6. Those are the last ones. You have this, and also I am asking due date December the 1st also. My recommendation, finish them before the lecture, so you can ask questions about those topics also. However, they are open until midnight. So after the review, you can still have the full day to continue working in your quiz and your homework. Those are the last activities, the quiz, the homework, and the final exam next week. That's it. About the final exam, something that is also open today is the link for you to test the logged on browser. Again, it's open this week with the quizzes and the homework. This link for the sample exam, please, you already know how to use the logged on browser. The only thing, excuse me, the only thing that I am asking you to do is go, you already have the software, click in the sample exam and take the exam. Again, if you use one question, how are you or something. The only goal is for you to test that your computer works with the logged on browser. Even though worked before, please test your system again. You maybe update your operating system. You maybe change your camera, something in the hardware of your computer, whatever. Test your computer again, so be sure that you can take the exam next week. The link is opening today with the quiz and the homework, so do this as soon as you can. You already know this. Any question about the lockdown browser, please let us know, but my assumption is you are aware of how to use this. Very, very important related the lockdown browser. I sent some emails to some of you pointing out violations to the rules. So please, if you receive an email from me, from the TA, and we point out something that was wrong, please do not make the same mistake again. Something about your environment, something about headphones, anything. Review, and any question regarding the rules, let us know. Key ideas. Your final exam is closed book. No electronic devices, notes, notebooks, or any kind of reference in your desktop when you are taking the exam. Closed book the exam. So very, very important. You need to choose your environment. You did this before, you received feedback about this, so take care of this. Scratch paper, as I mentioned before, as happened with the midterm, you can use a scratch paper. It can be useful in particular for the questions related with pointers, so you can draw your variables and where they are pointing and what is happening with the asterisk and the ampersands. I could recommend you to have scratch paper there. Just remember, when you start the exam, show the paper to the camera. Be sure that you show that the paper is empty. There are not notes or something printed there. Use white, empty paper. You can use that. Moving forward for today's topics. Okay, thank you. So you're going to have the survey about the topics. Great. Moving forward with the last topics. Previously, we have reviewed Prolog, and what you know right now is how to create facts. Hopefully at this point, after 3 lectures, you are very familiar with this and you agree that every single fact is going to start with a word, and that word represents in a sentence in English, the action, the relationship. Parentheses, a dot at the end, the dot, the end of the sentence, the objects, the parameters, the notes, the relationship. The relationship here, the notes inside. The graphical representation of what we are giving to Prolog. The verb, the nouns. With the facts, you can create rules. A rule is this combination of facts with this particular symbol. And hopefully you remember that one is an if. One fact, one condition. The condition is also a fact. So if this thing here happened, this thing here is also going to happen. If the first one is true, the other one is going to be true, and the opposite. The important thing here to remember for Prolog, the condition is not the first one, but the second one. This is the condition, this is the result. Tricky things for you to remember during the exam. Which one is the condition, which one is the result. Also, to remember, you can put facts together. You can use an important, this comma outside of the parentheses is an and. This comma inside of the parentheses is used a comma to separate parameters. Very different things, just because one comma is inside of parentheses and the other comma is outside. One is an operator, the other uses a delimiter. You can put together 2 facts or more with the and or operator. And again, this, the condition. A condition with two parameters, a condition with two ideas, two facts together with the and, that make the condition. If that condition is true, the result of whatever is the rule, the name of the first fact, that is going to be true also. Facts, rules, the if, the and, the or, the end of the line. So far, I think easy. We have reviewed several examples with this. Moving forward, something that we reviewed in the previous lecture, what happened with the queries. Queries, most important thing, everything that can be a fact here can be a query, just changing in which part of your interpreter you put that thing. Facts, this is a fact. Looks like whatever I put before. The only thing is, because I put this in a different screen, in a different part of the interpreter with a different prompt, the computer knows that that is a question. And for every single question, things for you to remember. If you have everything lowercase, if you do not have variables, always, 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 the answer is going to be only true or false, nothing else. It's true, it's false. True if I have that information, false if I do not have that information. True if you put this before here, and then you're asking for exactly the same, it's going to be true. If that line is here as a question, but it's not here, it's going to be false. Easy. But we introduce variables. Anything in uppercase is a variable. If you use variables, what you're going to get when you ask a question is answers. Answers. Most of the answers, by now you are aware, is searching for data, like a select in databases. You are searching for the data that correspond to this relationship, connections with a particular node, like in this example. All the connections with that name, with that particular node, give me all of them. The only thing that you need to do to ask for that, use a variable. And that happened with any relationship, and that happened in any position of the question. You can use variables here and here, both variables. And as we reviewed before, that is going to give you like a select all. That is going to give you all the connections for all the possible nodes. That is possible. You can do that. If you ask for anything that do not exist, again, your result is false. Even if you use variables, even if you put variables in any of these places, if one of the data, one of the elements that you're using, the node or even the relationship do not exist, you do not get an error. You get a response, an answer, and that is false. False, as we reviewed before, is false. That is not true. But also is the representation of null. The list is empty. There is no data about this. False, null, or not true. Facts, rules, queries. Finally, regarding queries, this can be kind of complex. We review this. I can pass variables or use variables here and also here. We're going to talk more about this today, but we're going to combine this with what we reviewed in the previous lecture, arithmetic queries. Arithmetic queries, a new keyword is the keyword for asking for the result of some arithmetic operation. Is asking a query about something that is related with math. Usually, variable is, and your query, your operation, like the variable is 10 plus 5. You can get a result, or if you provide a value, you can get true or false, like if you were using the equal. In my first example, the is use the equal assignation, but just like changing this instead of variable a number. Now is this. Now it's comparing data. Now, you can compare data, but also you can play with something like this or like this. And I want to be sure that we understand when we combine data, when we use this, the only thing that you evaluate according with the definition is what you have here. Whatever you put here is going to be evaluated. Whatever you put here is the arithmetic expression that is going to be solved. That is the reason because this 10 plus 5 is 15. The system is going to evaluate this. And this is going to be evaluated also. And this is going to be evaluated also. If you put before the is something like this operation and this operation, what the computer is going to do is, well, whatever you put here is use an identifier, is use a bunch of characters, is I am going to evaluate this. That is what I am doing. I am asking if 10 plus 5, whatever is that, the computer didn't care about trying to understand, is 15, because 15 was the result of doing this. Only what you put in the right part is going to be evaluated. And when I have this, the computer is going to check, well, this is not a variable, it's not this case in which I am trying to do an assignation. So I am trying to do a comparison. And if I am trying to do a comparison and I am trying to compare this and this, they are not the same. They are not the same. The reason is the left part is not evaluated, only the right part. Here, similar idea. This is not going to be evaluated, is this one is going to be evaluated. I am trying to evaluate x. X is a variable. And this is maybe the only error that Prolog is going to present to you, the most common at least. I am trying to evaluate x, and basically the error is telling me, you know what? I am trying to do something with the variable x, but the variable do not exist. You want me to compare if 10 plus 5 is equal to something, but this something, the variable have not been declared, do not exist. Do not exist because I do not have the x created before. We need to review how to create variables. But so far here, that x do not exist. This error that you're going to receive several times, maybe in your homework, when you receive an error like this, something with instantiation, what Prolog is telling you is, I do not know what is the value of this because you haven't told me what is the value for that variable. And therefore, if I do not have the value for that variable, I cannot make the comparison that you are asking me to do. We're going to work with this. I need you to remember, if you want to evaluate something in the right part, the left part is not evaluated, should be a value already. Putting this together with what we had before is going to be interesting. Now, one more note. You can put together arithmetic expressions with and. You can put together arithmetic expressions with ors. They are just facts. The important thing here is if you use this and or, the computer is going to try to do something specific. For instance, if you're asking me that x is this, okay, x is the result of that, is a number. And then you tell me and the x is 1, the result that you're going to get here is false, because what the computer is trying to do is to find a value for x that make those two facts true. A value that make x equal to that division, but also a value that make the other equation true. In this case, the equation is only the one. There is no value. that can solve both equations. And because there is no value to solve both equations, you are going to get this false. In other languages, could be an error. Here is used, you know what, false. There is no answer for what you are searching for. There is no way that you have one value for x that solve both equations. Remember the comma when you have arithmetic equations, and remember this result. This is going to be useful for what we're going to do now. And with arithmetic, good. The point is you're searching for a value that solves both parts. If there is no value, your answer is false. If you have a value, or if you change the name of the variable, for instance, now you are searching for an x that is equal to the division and a y that is equal to 1, you're going to get this result. You're going to get, okay, your x is this, the one that solves the division, and notice that Prolog is going to use the comma also for the answer. You can use and in your question, Prolog can use and in the answer. X is 1.6 and y is 1. That is your answer. When you ask for x being both, that do not exist, false. You can use the or. X is the division or x is 1. When you use the or, you are asking for two values for the same variable. Same variable, two different values with the or. If you use the and, you are asking for only one value for the variable. And only one. That is the reason because you get the false here. There is no one single value to solve both equations. Here, with the or with a different variable, you get two values. Two values for two different variables, two values for the same variable. Both work. Okay. Details, but so far, hopefully simple. Now, the important thing. Today I want to talk about recursion with Prolog. What do we need if we want to talk about recursion in any programming language? Recursion in Java, recursion in C, recursion in C++, even in Lisp. If we're going to talk about recursion, what is recursion? What do we need in order to do something recursive? What is that something? Do you remember? Okay, recursion is going to be this case. Exactly, thank you. I agree with the other answers, in particular, the starting point. We're going to move forward to the others, but the starting point. If we talk about recursion in programming, we're talking about functions. Think about Java. You review recursion. What is recursion? What is a recursive thing? It's a function calling itself. In Java. In C, the same. In C++, the same. Even in Lisp, it's a function calling itself. In all the languages, recursion connected with the idea of functions. A function that is using itself, right? And then we need to talk about what is going to be inside of the function. Inside of the function, and then I can use your other answers. In every single recursive function, we're going to have a condition. I am going to put here if, but you need a condition, the control flow, because you need two possibilities. You need something that is the best case, something that is going to happen to stop the recursion. If you remember with the factorial, the condition in which the user is asking for the factorial of 1 or 0, and instead of calling the function again, I use return a value, that point in which I am going to stop and start returning. And obviously, the recursive case. The recursion point, the point in which I am calling the same function. At this point, this should be familiar for you. Recursion is a function inside an if condition, inside of the if condition, giving the result or make the recursive call. Those are the key elements, right? The question is, what I do in Prolog in order to create a function? What I do in Prolog in order to establish a condition? What I do in Prolog in order to return the best case? And probably the recursive part is going to be the easy one. What I do in Prolog in order to, if I have a function, inside of the body of that function, call the same function. Those are the things that I need to answer today. Functions with recursion in Prolog. Well, let's start. First, a function in Prolog, the representation of a function with Prolog is going to be a rule. In particular, the function itself, the body of the function is going to be one part of the rule. The header of the function is going to be the other part of the function, the other part of the rule. Body, header. A function in Prolog is a rule. For instance, you know what? I would like to have a function. My function is going to be do something. This function is going to be returning an integer, and it's going to receive two parameters. And the body is going to be literally this could be a function in Java, C, C++, and I am sure that you can translate this to Lisp also. A little bit different, but same elements. In Prolog, what you need to do in order to create a function that is equivalent to this one, the only thing that you can do, facts, rules, and queries. The function is not going to be a query, it's going to be a fact, it's going to be a rule. The first thing that I need in my rule, the symbol, always. My function is going to be whatever name you have in the function, you can use as a name for the fact that is at the beginning of the rule. And then you have parentheses. Parentheses, like for the parameters. Parameters, we do not have data types. I am going to send as a parameter X and Y. These two guys. The name of the function and the two parameters. With that, you create the beginning of a rule. Moreover, you know what? We have an issue here. The rules do not return anything. I cannot have a function returning integers, not in Prolog. All my functions in Prolog, quotation marks, are going to be like, if I have a void here, help me. If I want to return a value, like I want to return a result, but I cannot use this here, there is any other way in Java, C, C++ in which I can get a result outside of this function without using this because I am void. I think you do this for the arrays. I think you do this returning something in a different way, not using this part for several different cases in Java, C, C++. Pointers, thank you. If I cannot return the result like this, what I can do is here, add another parameter, a pointer, a reference, you name it. But this parameter is not because I am going to receive something. I am going to receive the address, the reference. But the only reason because I am receiving the address, the reference of something is because I am going to put the result there. So instead of two parameters and returning something, what I have is three parameters, two with the data and the other with the address of the place in which I need to put the result. This is the way that Prolog is going to work. You're going to use parameters, not only for receiving information, but also for returning information. And there is a particular reason for that, and I am going to show you. So if I want to translate my original function, do something, receiving 2 parameters and returning 1 integer to Prolog, what I need to do is, well, my do something is going to receive those 2 parameters and another one for returning the data. Something like this. 3 variables. 2 are going to be data, 1 is going to be result. I can have obviously more variables with data and more variables with result, but all of them are variables. That is the first part. The second part, this is the if. I am not thinking right now like natural English and how to translate the if and so on. It's just by definition. The first part is the header of the method. The second part is going to be the body. The body, what I want to do is an addition of x plus y. I can do x plus y in Prolog. Well, but in order to do this, I need to use this keyword, a query for arithmetic expressions. So this is x plus y is going to be my arithmetic expression. X and y, variables that I am receiving as parameters. The value of those variables is going to be added. And then I use the is to ask for that to happen. And the is going to ask me to put here a variable. The variable where I want to store the result. Okay, let's use this R. And you can think about pointers. And I am receiving the address of a variable, and I am using this address as the input for my operator is. So in this address, is going to do the equation, get the result, put that result in this variable that, by the way, is a variable that something else shared with me. So what I am doing in this line, in use one line, is solving the equation with is and storing the result in a variable that is a parameter. Therefore, after I call the function, I will have the result of a plus b in the variable p. This is how do you create a function in Prolog. What if my function have more than one line? What if I have a function and that function have several lines? This is one line. You want to add more lines? You have 2 options. Number 1, if you only have one line, you have the dot at the end. That dot is kind of the curly bracket that closes the function. If you want more lines, number 1, you do not put the dot there, but you need to put something. 2 options, a comma or a semicolon. One line, comma or semicolon, another line, comma or semicolon, another line, and so on. The last one with the dot close the rule, the dot close your function. Which one to use, the and or the or, depending on the program that you are doing. I am going to show you examples, but you need a comma or you need a dot, a comma, a semicolon, or a dot. The dot to finish everything, the comma, the semicolon to connect more lines. These are functions in Prolog, the equivalent of functions in Prolog. Advantages. What I did is this function that the only thing to do is to add the numbers and return the result. Very trivial. However, you know what? If I run this line in Prolog, do something 3, 2p. You put that in the space for questions. You ask this question. You press enter. What are you going to get as a result? This is a question in your exam. The value for p. Could you agree with me that if you ask this question, what you're going to get is p equal 5. That is what you're going to get as a result. The value for p. Yeah. It's going to be the variable equal and the number. That is going to be what you get on the screen, period. What are you going to get if you put in the question size something like this? Wait, you are sending the values 3 and 2, but this one, that in any other programming language could be the pointer or the reference for the space in which you want the value, what you are sending is a number. Yeah. And the computer, your interpreter, is going to understand that I am sending a number, and your interpreter is going to create a variable, and inside of the variable is going to put that number. Those things are going to happen because of the interpreter. So don't worry, you are not going to get an error. What is going to be the result? Do something 3, 2, and 10. You're going to get that the result false. Are you telling me that this is the definition of my function, like this? And I have a function that is able to, number one, if I give 2 numbers as an input, can give me the result. Just like this. Yeah. The function is going to work like in the other languages. But also, are you telling me that I can send not only the input, but also the output, and automatically, just by default, I have not only the function that is able to calculate the result, but also to tell me, like in an if condition, if the result of this is equal to 10, because basically that's what I am doing. Yeah, that happened. I can do that. Good. So it's going to tell me basically 5 is equal to 10. False. It's going to give me the result false. That is great, right? I mean, think about it. You define a function, you get a functionality, and automatically, always, you get this possibility of true, false answer, a comparison of the value with the result that you return, just by default, automatic. Okay, good. Let's review something a little bit more complex. Yeah, we talk about the factorial. We review the factorial in Java, then we review the factorial in Lisp, and why not? Let's review the factorial in Prolog. You already know the factorial. You know which are the elements that you are expecting there. I mentioned that at the beginning. The function, you already know how to create the function. The condition, what's happening if the condition is true? What's happening if the condition is false? Prolog. Number one, you want this factorial thing? Okay. Every single thing here with the percentage and in green is just comments. So I just put those things there for you to remember. Comments. Even this and here are part of the comment, so you can delete those. Your factorial in Prolog. 2 things. What you need for the factorial is the following. Number one, the base case. The base case is going to be not part of the function, but a fact that you need to create first. What? Yeah. This line is not a function yet. It's not a rule. It's just one little connection between 2 elements, the 0 and the 1, and the connection is named factorial. What you are doing there is telling the computer, there are going to be something called factorial, and the factorial of 0 or 0 factorial is going to be 1. That is your base case, remember? If the number equal to something, the result is something, a relationship between two numbers, 0 factorial 1. And you remember that you start reading in the first parameter. Go to the function, then read the last one. 0 factorial 1. It's a fact. It's your best case. You use the final. Okay, that is easy. The best cases. The method. The method is to calculate the recursive part. The base is already there. The recursive part, well, we need to create a method. We need to create a method factorial. Wait, are you telling me that you can have a fact factorial and then you can create a rule factorial? Are you telling me that you can use the name 2 times? Yes. Do you remember that we use likes more than 1 time, or hot more than 1 time, or enrollment, or teaches, or whatever? Several times. It's fine. These 2 are going to go together. These 2 is one or the other is going to be used. Just like when you have a method and you have a condition. If the first parameter is 0, the computer is going to do this. If the first parameter is something else, whatever else, other thing that is not 0, the computer is going to apply this one. One or the other, the rule or the best case. Like when you ask here for classmate and you put information here, you are searching, and if the first parameter is Joseph, you check with Joseph. If the first parameter is another thing, you check with another one. Similar for the functions. First parameter 0. First parameter is other thing. Now, your method. I need to receive 1 parameter, right? The factorial method receive a value, the value that you are going to use to calculate the factorial. 1 parameter with the value. The function need to return something. Yes, I need to return something. The function factorial return an integer. Okay, here you cannot return things. If you need to return something, use another parameter. My function factorial for Prolog is this 1 fact 0 1, and this one rule with 2 parameters, n and f. It doesn't matter the name. The only thing that you need to remember, uppercases. That's it. Okay, that is the header of the function. The next thing is we need the body. The body. This is the symbol that is going to separate the header and the body. For the body, here is the important thing. You notice that I have several lines because the rule is finishing here. 1, 2, 3, 4 lines. 4 lines, and they are connected. They are connected with and, the comma. The comma is the operator and. The and is being used here a lot. It's not just the comma to separate lines, and I need to be clear with this. What you're doing there with these commas is and. You have a big condition for this rule. Remember, this is an if, and all the things that you have inside, the condition that are going to create this true or not. Anyway, the body. Inside of the body, number 1, n greater than 0. If you want to calculate something, you use is. If I do not put the is, I am not calculating anything. is just a comparison. N is greater than 0. The result of that is going to be true or false. What happens if the N is not greater than 0? If the N is not greater than 0, that is kind of your replacement for the if. Use the condition. If the N is not greater than 0, this thing here is going to be false. What happens if you have the first one false, and then is and something else, and something else, and something else, the dot? The first part is false. N is not greater than 0. If that is false, what is going to be the result of everything else? An operator, one element is false, all the others are false. You know what? Similar to happen with Java and C. If you already know that the answer for the first element in a logic expression with AND is false, you do not do the others. This is like your condition here, if, whatever, and you do not have an else. If this condition is false, you go to the out of the method. The same is going to happen here, used with the condition and all the other lines with commas. The first part is false. All the others are not going to be executed because they do not need to be executed. The result is false for the full condition that we have here. Okay, and moreover, if the result there is false, probably because the number is 0, and we already have this here to replace that. So that is what we want to do. Do not run the function, but run the base case. Okay, let's assume that the condition is true. Let's assume that we are using this factorial with a number that is greater than 0. If this is true, then we can continue with the other elements. What is going to happen there? Because that is the next one that is going to be solved. N1 is N minus 1. Can you figure out something like this? It's a local variable. The local variable can have whatever name you want. I am using uppercases. It's a variable. The number is just going to help you with the reading, but this is a local variable. It's a local variable. What is the value for the local variable? This operation. One thing that happened here, we cannot use operations as parameters for other actions. Here, we need a lot of local variables. Here, for every single thing that we do, we need to store the result in a particular variable. The only thing that we can use as parameters are the variables. So you're going to notice a lot of new variables. The good news is you do not need to declare the variable. There is no data types. So every single time that you need to do an operation like n minus 1, the is the one that is going to do the operation. And you can put here any name for any variable. But be careful, you cannot use n because maybe you want to use n later, like for this multiplication. So that is the reason because we use another one. Here, any mathematical operation, if the operation can be done, the result that is going to be reported is true. If I can do the operation, I report true, or that success is like, yeah, everything good. If for any reason the operation cannot be done, something crazy, division by 0, the report is going to be false. So you can imagine that line, n1 is n minus 1, it's going to be done. It's going to report true. The first one is true because the number is greater than 0. The second is true because the operation n minus 1 is going to be done. Second line is going to be true. Moreover, now I have a variable n with a particular value. Now I have a variable n1 with a particular value that is n minus 1. I have two variables that I can use. I can continue. I am going to continue. And what I am going to do moving forward, call the same function. When you have a recursive function in Prolog, what you're going to have is a rule that have the same factorial in the both sides, before the condition and after the condition. That is a recursive function in Prolog. Factorial here, the colon, the minus, the if, factorial here, again. Obviously, this factorial here is only going to be executed if these two lines before were true. The line that is comparing the value and the line that is doing the minus. If those two were true, we are running the third line. Other case, we're out of here. The third line. Can you notice what is going to happen here? What is happening? I am calling the method factorial. I am calling the method factorial, and what I am doing basically is to ask for the factorial of n minus 1. I cannot put the operation here inside. I use the variable that I calculated before. This factorial, I usually will store here, this one, in a variable. I cannot do that in Prolog. What I can do is to put this variable as a parameter, f1. I am doing a recursive call, same function, with another value, a smaller one. That smaller one is going to return a result. The result is going to be stored here. And you can imagine what happened with the recursive calls. If you have a function, that one is calling another one, and that other one can call itself again and again and again. And what you have is a tree of executions. In some point, one of them is going to return. And you can guess, it's going to return when I call the function with the value 0, because at that point, this condition is going to be false. In that point, the computer is going to search for a new option, and that new option is going to be that one that we create there. And in that point, we're going to get the 1. I am going to run this in a moment, but let me finish reviewing the lines. I am going to ask for this recursive call. In some point, it's going to return, and with this return, the result is here, but that is considered true for Prolog. So 1, 2, 3 lines true. I continue with the next one. I continue with the next one, and the only thing that I am going to do in the last one is an operation, another arithmetic query. The arithmetic query, multiply n, the parameter that I receive, times f1. f1, the recursive value of n minus 1. That is the definition of factorial, right? Factorial of 5 is 5 times factorial of 4. And dot. Two things are going to happen. This f, the variable in which I am storing the result, is a variable that I receive as a parameter. The user that is asking for the result can have access to the result, can have access to this if they put a variable. The other option is if the user put here a number. What they are going to get as a result is true or false. because this line is going to store the result here, but also it's going to return true or false if the calculation could be done. Moreover, if you give me a value for this f, it's going to return true or false depending on this value being equal to whatever is the calculation after the is. With this factorial function, you can call something like this, and I am going to review this. You can ask for the factorial of a number, and you can pass as a variable, and you can get the result of the factorial in the value of that variable. But also with that one, you can ask for the factorial of 3, and you can pass a value like 7, and you are going to get as a result this, just because 7 is not the factorial of 3. This work and this work with the same function. Good. Really? This work? Yeah. Let's check with details. Number one, what happens if you put this and this inside of your interpreter in the first column, in the column for the facts and the rules? The computer knows this and knows this. Know information and know a process, a rule. Done. Then I go to the section of the questions, and in the section of the questions, I am going to start playing with this. And the first question that I could ask is, well, something simple. Tell me, what is the factorial of 0? And I am going to use variables. If I ask for the factorial of 0, when I ask that, the computer is going to go to the database, and inside of the database, it's going to search, do I have something like factorial 0? Because those are the information, right? This is uppercase, and because it's uppercase, it's not information. Go to the database, search factorial of 0. Do I have something like that? Yeah, you have factorial, and you have this 0 here. Okay, I am not going to use the rule. I am going to use this one, because match. Match, and the computer is going to tell you, you are searching for a variable. The variable is going to be 1. This one is this one here. Remember, it's a database. You are searching for information, relationship, first element, go to the database. Okay, I have that relationship, I have that element, and they are connected. 0, factorial with the 1. That is the reason because you get the result of 1 when you ask for the factorial of 0. Yeah, it's going to say true, 3 and 6, because you enter the value that you want to calculate, you enter the result, it's going to tell you true. So factorial of 0 is trivial, simple. Next, what happens if I ask a question? And the question is, you know what? Factorial 1. And again, a variable. Factorial of 1. What is going to happen in the database? The database is going to search for match of factorial of 1. And in the database, it's going to say, okay, I have this factorial 0. Remember, it's searching for data. And these do not match, because this one do not match the number that the user put there. Okay, this is not useful. Do I have other options? Oh yeah, I have this one. Okay, this one, factorial, match. And you know what? This is a variable. So because it's a variable, I can put the 1 there and see what happened. The computer is going to run and it's going to do factorial of 1. 1 is the value for your n. And whatever is going to be the value of f, this f is what the computer is going to report here as the value that you are searching for. The only thing that the computer is going to do is, okay, I am going to run this rule, and whatever thing finished in F, I am going to report in X, because this X, the variable that the user is using, is in the same position that this one. Okay, good. Then I am going to run the rule. I am going to run the rule. N is 1 because the computer is using this rule with the value 1, like passing parameters. Okay, step number 1, the first line. 1 is greater than 0. And as you notice, now we have a particular case. 1, the value of the variable, greater than 0, and the answer is true. True. Continue. Because this is a condition. You have true, you have and, true, continue. You can go ahead. 1 is okay. Okay, next step. Calculate n minus 1. N minus 1, 0. And please store that 0 in another variable. Now you have a variable n1 equals 0. It's kind of a local variable. You can do that? Yes. Check. True. Continue. I have the 0 and I have the 1. Next step. You know what? I need you to calculate factorial. Factorial of what? n1. Who is n1? 0. And whatever is the result, put the result in F1, another variable. So you're going to have a value for F1. You are looking for the value of F1. Okay, I am looking for the factorial of 0. What I need to do is, I am not going to return to this point. We are not in this kind of programming. What I am doing is, go to the database, check for all the relationship factorials, and tell me, you know a relationship between the 0 and factorial? And it's like, yes, I have one. This one. So you're asking me for the relationship factorial 0 and something else? I have information for you. This something else is 1. Just because if you put the 1 there, this is true. This is true because I have the information. Remember, every information that I have, the result is true. Okay, so are you telling me that the value for F1 is 1? That makes the sentence true, and I can continue. It was not exactly recursion. It was go and search for the data in the database. You found the data. You have the data, continue. Okay, good. So the last line, multiplication. Multiplication of n. N here is 1, the parameter. F1 was 1. F is going to be the multiplication of them, 1. This is going to be the value for F. This is going to be here. And therefore, is the value that the computer is going to tell me, you know what, your factorial 1 and your variable can be 1. And that is true. And that is true because all of this sentence were true. If I ask factorial 1x, my result is going to be x equal 1. If I ask factorial 1, 1, my result is going to be, yeah, true. 1 is the result that I am getting to. Okay, this was so simple. For the 0, searching, I get the data. For the 1, I use the rule, and the second time, I use the data. What happened with that 2? What happened if I ask the question, factorial 2 and a variable? Well, again, factorial 2. The computer, go to the database, check if you have information about this. Check if you have information about this. Not here. Sorry, no information, no facts. Oh, well, we have a rule. Use the rule. Notice that I am using rules as a second option. The first thing that I search for is facts, have the information. If I do not have the information, but I have a rule with the same name, then I run the rule. If I run the rule, factorial of n, what you are asking me to do is to make that n equal to, you are asking me for the value of f, and whatever is the value of the f is what you are going to report here as the value for this x. Did you notice? X here, f here, but they are the same pointers of references. Complexity is hidden to the programming. Now, moving forward, line number 1, n is greater than 0. Yes, it's 2. Pass. Second line, n1 is n minus 1. Okay, you're asking me to calculate a variable n1, and you're asking me to do that 2 minus 1. So that one is going to be 1. Okay, I can do that. I did it. Pass. Next one, you are asking me to calculate the factorial of n1. You are asking me to calculate the factorial of 1. And you want the result in a variable f1. You're asking me to calculate this variable, factorial of 1, here. What is going to happen? Go to the database, search. Do we have the factorial of 1? And the computer is going to check this one, and it's going to say, no, we have the 0. Okay, what do we need to do? Apply the rule again. In this point, we are doing the recursion. Apply the rule again. Yeah, apply the rule again. We need to finish this one, but because we need the factorial of 1, what you're going to do is run the rule again with a value n equal 1. You are searching for a value for function, and this is the value. Whatever is here is the value that you are going to connect and use here as an f1 pointers. We already did this, remember? When you are going to calculate the factorial of 1, you are going to run this rule from the beginning, which means checking this again in a different part of the stack, in another execution. 1 is greater than 0, yes. Can you calculate n minus 1? It's going to be 0. n1 in this instance here is 0. Is another n1 different than this one, that is 2 minus 1? Remember, recursion, 2 different places of the stacks. It's going to pass. And then you're going to ask for the factorial of n1. You're asking for the factorial of 0. You're going to go to the database, and in the database, you're going to find this one. And this one is going to give you the result. The result for your f1 is 1. This one here. Check. And then you're going to do this n1 multiplication 1, and that is going to be the result for your f. This one is going to be 1, the multiplication of this n and this f. And this one, when you finish this, you go back to the other rule that you are running. You go back to this line here with the result of 1 in this execution line that we have before. Now you have the factorial of 1. The factorial of 1 is 1. Check. And now you can do the next line. The next line, the multiplication of the factorial of 1, f1, that was 1, times n. Which n? This one, the one that have the 2. Do you remember? We already finished with the n1. We are with the n2. 2 times 1. I can do that. Yes, you can do that. And store the result in f. That f. What else? You are done. You have these 2 here as a result of factorial of 2. That is going to be the result for the f. That is going to be the result of your x. Factorial of 2 is 2. Factorial of 1 is 1. And what I am sharing with you guys, the execution for calculate factorial of 3. That you can imagine is going to ask for the factorial of 2. So all of this is going to happen. That includes the factorial of 1 that happened before. The recursive calls. This is how you create methods in Prolog. Moreover, the most complicated methods, the recursive one, this is how you define recursive methods, in particular, the factorial. Please review this. Be sure that everything that I explained regarding how this is working is clear. If I put a negative number, what do you think is going to happen here? Yeah. It's not an error, but it's not going to find the result for this question. It's not going to find this 0. The negative number is going to continue growing forever. You're going to get in some point a stop because the overflow, but that is going to be false. No a result. Not working, then false. Not working, but working, it's going to try to continue working as far as the results allow this. So if you ask for the factorial of 1 million, it's going to continue working until the overflow in some of these different stack copies. Good. So this is the factorial. My challenge for you, something that you can use to study during the week. What happens if I ask you for another classical example, the Fibonacci, the recursive Fibonacci? Important things, your best case for the Fibonacci usually include 2 things, the Fibonacci for 0 or the Fibonacci for 1. They are respectively 0 and 1. You can define these 2. It's fine. And then you can define your rule. And the dot for the n. And if you remember, if you check the version in Java or C++, the Fibonacci recursive call twice the recursion. You calculate the Fibonacci of 2 things, the number -2 and the number -1. I am using this one line. Remember, in programming, you can have everything in one line. The only reason for different lines here or different lines here is allow you to read. Hopefully you notice what is happening there. I need the Fibonacci of the number -1 and the number -2. The first thing that I need to do is calculate those numbers, store in a variable, and then use the variables as parameters, and then get the results in other parameters, and then the final result is the addition of those parameters. Only one condition, we need to be above of 1. If we are below of 1, I already have the results. As previously, if you have negative numbers, you do not want to run this, not the others. Pretty straightforward. My recommendation, check this, run this in your interpreters. Moreover, be sure that you understand how this run, because for sure, there are going to be at least one question in your exam about this. And that's it. Any question? Okay, guys, so see you next week for the review. Thank you.